And we're back for our final video in our radicals unit. Now we're going to talk about dividing radical expressions. And specifically, we're going to be talking about how we rationalize radical denominators. So we talked about multiplying radical expressions, and we said that when you multiply, you can actually simply multiply the two numbers that are under the radicals together, like radical 2 times radical 3 equals radical 6. So here's my question. If I had radical 12 divided by radical 3, could I simply do the same thing I do with multiplication, and that is put everything under the radical sign? Is this the square root of 4, which is 2? Is radical 12 divided by radical 3 2? Well, let's take a look at it. There's lots of different ways I can look at it. Here's one way I can look at it. What is radical 12 if I simplify it? That's 4 times 3, isn't it? Pull the 2 outside, and I get 2 radical 3 over radical 3. What do you know about factors that appear on the top and bottom of a fraction? They can cancel. So this answer is 2. So that kind of checks out, doesn't it? Yep, it does. Okay? So we can treat division just like we treat multiplication. Let's go ahead and write an algebra rule for that. If I have radical A over radical B, that's the same thing as radical A over B. So that does work. Okay? All right, so we're going to take a look at a couple of other examples, and then I want to get back to this particular example here because there's something we need to look at there as well. What if I had radical 8 over radical 6? And again, there's more than one way to do this problem, but I'm going to stick with this rule that I just gave you, which was this, radical 8 over radical 6. Okay? Doesn't that reduce? Yeah, it's 4/3, isn't it? And if we do this rule in reverse, what do we get? We get radical 4 over radical 3. What's radical 4? 2 over radical 3. Now that seems nice and simplified, doesn't it? Certainly seems more simple than radical 8 over radical 6. Here's our issue. We have an issue in math. It's kind of an old issue, and we really don't have to concern ourselves with it so much anymore. It comes from the days when there weren't calculators. But it's something we've hung on to in math, so it's still around. And that is, we do not like to have radicals and denominators. It is not acceptable to have a radical and a denominator at this point in your mathematical careers. So what we have to do is we have to rationalize the denominator. That means we have to turn the denominator into a rational number. Radical 3 is an irrational number. It cannot be written as a fraction. That's what the word rational number means. So here's what we do to rationalize the denominator. When we rationalize a denominator, all we do is we multiply the top and the bottom of the fraction by whatever radical is in the denominator. Once again, multiply the top and bottom of the fraction by whatever radical is in the denominator. 2 times radical 3 is 2 radical 3. Remember, you cannot multiply what's inside a radical times something that's outside a radical. Okay? And then radical 3 times radical 3. Remember our multiplication? What did we say about multiplying a radical times itself? All it does is get rid of the radical sign. 3. There's my answer. Now, you may think that this answer right here seems more complicated than the original problem, and it kind of is, but we do have to stick with rationalizing the denominator because that's what you need to be doing. Okay? Look back at my first problem that I did. I did a problem way up here, radical 12 over radical 3. Let's do it another way, okay? Let's rationalize the denominator and see if we come up with 2 as the same answer. So I've got radical 12 over radical 3, don't I? I can rationalize my denominator by doing radical 3 over radical 3, right? What do I get? Radical 12 times radical 3 is radical 36 over radical 3 times radical 3, which is 3. But radical 36 is 6, isn't it? 6 divided by 3 is 2. We get the same answer. We get the same answer. Okay? All right, so I think we probably need to do one more of these simple rationalizing before we move on to something more complicated. Let me make one up here for you. What if I have radical 5 over, let's say radical 15. How's that? Is radical 15 as simple as it can be? Yep, because it's just a 3 and a 5. This is 3 times 5, so there are no pairs. Okay, how do we rationalize our denominator? We multiply top and bottom by whatever radical's in the denominator. Okay? Radical 5 times radical 15 is radical 75 over radical 15 times radical 15 is just plain old 15. And then make sure you simplify. Okay? Radical 75, let's simplify that. Radical 75 is 3 times 25. There's a pair of 5s right there, so the 5 comes out. 5 radical 3 over 15. And then we just want to make sure that we can reduce whole numbers if necessary. Take a look at these whole numbers right here, and you tell me what we can do with 5/15. Can that be reduced, 5/15? Absolutely, to 1/3. But I don't write a 1 in front of a radical, do I? Nah. I don't write a 1 in front of an x, so I don't write a 1 in front of a radical either. There's my answer. Okay? Again, make sure that if there is a number in front of the radical that you don't multiply any numbers outside times numbers that are inside. Okay? I think we could stand to do one more. Let's do radical 72 over 2 radical 3. Just making this one up. Okay? Now again, we could simplify radical 2 right away, 72 right away if we wanted to. And actually that would probably help with this one. But let's say you didn't do it. You would multiply top and bottom by radical 3, because that's the radical in the denominator, isn't it? What would we get? We'd get radical 216, that's kind of ugly, but that's what it is, over 2 times radical 3 times radical 3 is 3. Okay? Let's see what 216 gives us. That's 2 times, what's that, 108? 2 times 54, 2 times 27, and 27 is 3 3s. So radical 216 is 2 times 2 times 2 times 3 times 3 times 3. Okay? What happens when you reduce that? A 2 comes out, and a 3 comes out. So what do I get? I get 6 radical 6. Right? But that's over 6. So what happens? Bam, bam. We're left with radical 6 as my answer. That's the final answer. Okay? That problem might have been easier if we had simplified radical 72 to begin with. Okay? And I'll leave you to do that. All right, one major issue, and that is what happens if we have more than one term in the denominator. And I'm not talking about factors that are multiplied together. I'm talking about things that are added, subtracting. Okay, let me give you an example. What if I had radical 3 over 2 minus radical 2? Very, very different problem. Here's the issue. If I simply multiplied by radical 2 on the bottom, it would get rid of that radical, but it would just create another radical here. So there has to be a different way of doing these. And what we're going to do is we're going to multiply the top and bottom by something called the conjugate. And all the conjugate means is you change the sign between the terms. Okay? And I can do it with just about anything. If I had radical 3 minus radical 5, my conjugate would be radical 3 plus radical 5. If I had radical 6 plus 4, my conjugate would be radical 6 minus 4. Let's see how that helps us. So what you're going to do is you're going to multiply the top and the bottom by the conjugate. So we're going to multiply the top and bottom here by 2 plus radical 2. 2 plus radical 2, which is the conjugate of what we had on the bottom. See, on the bottom we have 2 minus radical 2, so we're going to be multiplying by 2 plus radical 2. Let's see how that helps us. On the top, we have radical 3 times 2 plus radical 2. Well, that's just distribution, isn't it? Just distributing. 2 times radical 3 is, don't multiply something outside times something inside. 2 radical 3. And what's radical 3 times radical 2? Radical 6, isn't it? Okay? Now, let's look at the bottom. This was 2 radical 3 plus radical 6. Bottom's a little different. We have 2 ways of dealing with the bottom. The first method for dealing with the bottom is just simply foiling. Let's foil. First, 2 times 2 is 4. Outside, 2 times radical 2 is 2 radical 2. Don't multiply outside and inside. Inside, negative radical 2 times 2 is negative 2 radical 2. And my last terms are negative 2 radical 2 times radical 2. Well, radical 2 times radical 2 is 2, isn't it? So we've got minus 2. Negative radical 2 times radical 2 is negative, and then radical 2 times radical 2 is 2. What happens here? These cancel each other out, don't they? So what are we left with? We're left with 4 minus 2, which is 2. So this whole thing is over 2. There's my answer. Be aware that sometimes, and make sure that when you get done, you simplify any radicals that can be simplified. Neither of these can be simplified, so we're all set. Okay, but you may have a situation where you may have to simplify some radicals on the top. Also, you need to look at the whole numbers that end up in your answer. The coefficients, if you want to call them that, although they're really not in front of variables here. Okay, there's a 1 in front of this. Okay, if those have a common factor, those can be reduced as well. Okay, one more problem, and I think we've got this covered. So make sure you simplify and reduce as much as you can your final answer. Okay, let's go dive right into the deep end here and do a pretty difficult one. How about, let me switch back to black here. I have minus 5 minus 4 radical 2 over 5 plus 3 radical 2. What am I going to multiply top and bottom by? You know, the conjugate, which in this case is 5 minus 3 radical 2 over 5 minus 3 radical 2. Let's do the top first. What have we got? We've got negative 5 minus 4 radical 2 times 5 minus 3 radical 2. We're going to have to FOIL this. Negative 5 times 5 is negative 25. Outside, negative 5 times negative 3 radical 2 is plus 15 radical 2. Notice how I did not multiply anything outside times anything inside. Inside terms here, negative 4 radical 2 times 5 is negative 20 radical 2. And then my last, negative 4 radical 2 times negative 3 radical 2. What's negative 4 times negative 3? Positive 12. And what's radical 2 times radical 2? 2. What do we get? 24. Plus 24. So let's combine some like terms then. What have we got? Negative 25 plus 24. Negative 1. Is that right? Yep. 15 radical 2 minus 20 radical 2 is negative 5 radical 2. Now let's look at the bottom. Move this up here. There we go. Our bottom is 5 plus 3 radical 2 times 5 minus 3 radical 2. Let's FOIL it. 5 times 5 is 25 outside. 5 times negative 3 radical 2 is negative 15 radical 2. Inside, 3 radical 2 times 5 is plus 15 radical 2. And then my last, 3 radical 2 times negative 3 radical 2. 3 times negative 3 is negative 9. Radical 2 times radical 2 is 2. So this is going to be minus 18. Once again, you'll notice that's because we're rationalizing denominator. There shouldn't be any radicals left in our denominator if we've done it right. Those two terms cancel each other out. 25 minus 18 is 7. This is 7 on the bottom. There's my answer. Okay? And notice what we've done. Our original problem had a radical in the denominator. Our final answer does not. And that's why we call it rationalizing the denominator. Now, some of you may have noticed, and I hope you did, that what we're really doing in the denominators, we're doing the difference of two squares. Remember this? If we had x plus 3 times x minus 3, you should know from Algebra 1 and from earlier in this year that that's x squared minus 9, isn't it? It's the square of the first term minus the square of the second term. The square of the first term minus the square of the second term. So that's really all we're doing here. What have we got here? 5 plus 3 radical 2 times 5 minus 3 radical 2. What is that? That's the first term squared minus the second term squared. It's the difference of squares. What's 25 squared? 5 squared is 25 minus, and then if we have 3 radical 2 times 3 radical 2, that's 9 times 2 is 18. We get 7. Everyone see that? That's actually probably the easier way to deal with the denominators in these rationalizing denominators when you use the conjugate. Is just go ahead and use the difference of squares. Again, it's the square of the first term times the square of the square of the first term minus the square of the second term. Okay? That is how we divide radicals and how we rationalize denominators. And again, we didn't do any problems that had these issues that I talked about up here, but that is if we need to simplify as much as we can in the numerator when we're done, and if we have any common factors that appear in these whole numbers in the final answer, you can also reduce those as well. But it has to appear in all of the whole numbers in all of the terms. There has to be a common factor. For example, let me just give you a quick example. This doesn't relate to any of the problems that we've just done, but if I had, say, as a final answer 4 radical 2 minus 8 radical 3 over, say, 16 radical 5, those three whole numbers have a common 4 in them. Do you see that? So I could actually write the final answer as radical 2 minus 2 radical 3 over 4 radical 5. In other words, dividing each of them by that common factor. So again, make sure your answer, all of your radicals are simplified as much as they can in your final answer, and reduce any whole number factors that might appear in your final answer. Okay? That's a lot for a whole video, but that's what you do when you divide fractions. Okay? And again, if you have a fraction in the denominator, you need to rationalize that denominator, either by as we did up here, simply multiplying the fraction by the radical that's in the denominator, top and bottom. And by the way, that fraction equals 1, doesn't it? That's why we can do that, because it's the same. Or if we have a binomial in the denominator, in other words, something with two terms, we multiply top and bottom by the conjugate. And again, this fraction is equal to 1 as well, isn't it? Okay? That takes a lot of practice, so make sure you practice some of those. And that finishes up our radical unit. Next stop should be imaginary numbers. Kind of fun. We'll see. Bye.